What's up, guys? Oh shit, you know what I just realized? I forgot to put a black shirt on. I always try to wear black shirts so no one can tell that I record on different days. And now my trick is my secret's out. And the chat works today, Sasha, so that is exciting. I saw that before I took it live. So that was exciting. I wish there was a way I could control it, but it works. So that's all that matters. Yeah. I hope everyone had a good weekend and a good start to the week. I worked on some performance issues of my website, elixirmentor.com, so that was exciting. I was using Highlight.js to convert markup text for my blogs and stuff, and so that's obviously all front end, and so there was a delay. You would see like the unformatted text and then it would, flash to being, the correct syntax. So I started using Earmark, which is an awesome library, and that takes Markdown and converts it straight to HTML, which is pretty dope. So I'm server-side rendering now all the Markdown text from my blog, and so it's just a lot more instant. It's dope. But I did have to do a little trick for the code snippets, and that was pretty cool. All I ended up doing is I'm still using Highlight.js for the code snippets, but I'm finding, like the backticks and language and creating like the pre-code syntax for the HTML just on those elements. So it's a lot smaller chunks of my HTML that's getting rendered after the fact, after the page load. So it's working a lot better. I like it. Today's going to be fun. We're going into the Elixir Getting Started guide, and we're going to be going through protocols, and protocols are pretty exciting stuff. So I will go ahead and let's get a web browser open. And we're going to go to elixir-lang.org, and I got to show my screen. And I'll make this a little bigger. All right, and then we're going to go to guides here. And then on the left side, we are going to find protocols. Okay, hopefully that's readable for everyone. Today, it looks like, oh yeah, we're going to be in our IDE a little bit. So we're not going to be in the Elixir shell too much, which I think is better anyways. So let's get the party started. All right, protocols are a mechanism to achieve polymorphism in Elixir, where you want the behavior to vary depending on the data type. We are already familiar with one way of solving this type of problem via pattern matching and guard clauses. So let's consider the simple utility module that would tell us the type of input variable. All right, so I think we should probably open up our terminal. Wrong screen. I'm going to make this a little bigger. And let's see, CD to the desktop, and then we'll say mix new, and we'll call this protocols. And then we'll CD into our directory. Okay, and then let's open up VS Code. And we can close this, and let's see here. We will create a new .ex file called utility.ex, and then we'll make a def module. Come on. Oh, it doesn't, oh, there we go. A little delayed. I didn't think autocomplete was going to work for me. Is this big enough for everyone? Well, where's my screen? It probably is big enough. All right, cool. All right, so consider a simple utility module that will tell us the type of input. And in this example, we're just writing a bunch of functions with pattern matching and with guards. All right, so we're just creating a function called type, taking a value, and then we're using a guard. And we're saying is binary, is underscore binary, and we're just checking it on the value passed in. And if it is binary, we're just returning a string that says it's a string. And then we're going to do the same thing, just to repeat this when, and then we're going to check when it is an integer to the same value being passed in. And then we're going to just return a string of integer. So this is just telling us the type we're returning, right? And we can test this out with ix-s mix. I'm going to clear this so we're at the top. And if we say utility.type, and if we pass in an integer, we get integer back. And I spelt integer wrong, but we're not going to be keeping this example long. Integer, there we go. So you see how that works. Now, why won't this work? Where is my browser? There we go. If the use of this module were confined to your own project, you would be able to keep defining new type arity1 functions for each new data type. However, this code would be problematic if it was shared as a dependency by multiple apps, because there would be no easy way to extend its functionality. This is where protocols can help us. Protocols allow us to extend the original behavior for as many data types as we need. That's because dispatching on a protocol is available to any data type that has implemented the protocol. And a protocol can be implemented by anyone at any time. Here's how we could write the same code functionality as a protocol. So if we were to rewrite this, and obviously there's a lot of reasons why you wouldn't want to do this, because one, it would check everything in order, and you might not be able to cover every case, or you could, but it could become very confusing. So if we were to rewrite this as a protocol, I'm going to delete this, and instead of def module here, we're going to say def protocol. Whoops, let's delete the autocomplete do block there. And then we're going to just do an @spec here, and it's going to take type T, and it's going to return a string because it's just returning our string of our type, right? And our protocol is going to have one function called type, and it takes a value. All right, so that's our protocol. And then to implement our protocol the same way, so we're going to cover bit, string, and integer. You just do def implement, and then you do the name of your protocol. Ours is utility, right? And this is going to be for type bit string. All right, whoop, bit string. And then we're going to just create our def type function here, and it is going to take a value, and we don't care what that value is because the implementation is only going to implement it for a bit string. And then we're going to return our string. All right, and then we're going to do this again for integer, so def implement, and then for utility again, and this time it is for the integer. And then inside here, we're going to do the same thing for our type function. It will take a value that we don't care about, and then we're going to return the string integer, so we get our type back. All right, so when we define the protocol using def protocol, arity2, its functions and specs may look similar to interfaces or abstract base classes in other languages. We can add as many implementations as we like using the def implement arity2 function. The output is exactly the same as if we had a single module with multiple functions. So this works the same exact way as the multiple functions that we did with the guards. So let's pull up our IX shell, our terminal. We'll recompile. And now if we do utility.type and we pass in a string, wait a second, we have to, foo is not did I do bit string? No, my bad, guys. We need, oh yeah, bit, let's see, bit string. No, we don't want that. Bit what was the, let's go up again, back to the code. Is binary bit string. So foo is not being recognized as a bit string. I feel like I'm calling the wrong, let's see, bit. Camel case, bit string. Is that what I'm doing wrong? Did I have camel case or did I not have camel case? I don't remember now. All right, recompile. All right, let's try this again. So utility, type, and then we're passing in our string, and there we go. Thank you, Sasha. And anyone else that was helping me, because clearly I'm special when I'm live. So so this is working the same way as our multiple functions, right? So even if we did utility dot type and then we passed in our integer, now we're getting integer, and now it is implementing our protocol, which is pretty cool. So let's go back to our code. Dun, dun, dun. So with protocols, however, we no longer are stuck having to continuously modify the same module to support more and more data types. For example, we could spread the def implementation calls above over multiple files, and Elixir will dispatch the execution to the appropriate implementation based on the data type. Functions defined in a protocol may have more than one input, but the dispatching will always be based on the data type for the first input. One of the most common protocols you may encounter is the string.chars protocol. Implementing its toString arity1 function for the custom structs will tell the Elixir kernel how to represent them as strings. We will explore all built-in protocols later. For now, let's implement our own. All right, so an example. Now that you have seen an example of the type of problem protocols help solve and how they solve them, let's look at a more in-depth example. In Elixir, we have two idioms for checking how many items there are in a data structure: length and size. So length means the information must be computed. For example, when we use the function length and we pass in a list, it needs to traverse the whole list to calculate its length. On the other hand, tuple size and byte size do not depend on the tuple and binary, as the size information is pre-computed in the data structure. Even if we have type-specific functions for getting the size built into Elixir, such as tuple underscore size arity1, we could implement a generic size protocol that all data structures for which size is pre-computed would implement. The protocol definition would look like this. So we do our def protocol, we call it size. We can put some documentation in here, sure. So it calculates the size, not the length of a data structure. And then it's going to implement a function called size, and it's going to take data. All right. So the size protocol expects a function called size that receives one argument, the data structure we want to know the size of. To be implemented, we can now implement this protocol for data structures that would have a compliant implementation. All right, so let's go ahead and do this. All right, so we are going to create our def protocol called size. We'll make a new file. Come on. So size.ex and then def protocol size. And we'll put in our documentation here. All right, so calculates the size and not the length of a data structure. And then it's going to just have one function. So def size, and it takes data. Okay, cool. So now if we wanted to, we could do the def implement in other .ex files. It doesn't matter, right? So it'll still work for us. But for the case of the example, we'll do everything just below so we can see everything. So now if we say def implement, we're going to say we're implementing the protocol size. And this is for a bit string, camel case. Don't type it as not, or you'll make silly mistakes on a live stream. All right, and then we're going to take our size function, and that's going to take a string. And then, so since we're looking at a string, we now want to say byte size and pass in the string value, okay? And then we're just going to repeat this. We can do this for def implement size again, and then we can do it for data type map as well. And for this one, we are going to do the size function, take our map, and then we can do map underscore size and pass in our map. So for a lot of our data types, we have these nice built-in functions that allow us to use them, right? And since we're just creating our own protocol, we can call them all now with the same function call, and the data type is automatically associated through all of our protocol implementations, which I think is pretty cool. And then we'll do def implement, and we're implementing this for protocol size. And now this one is for the tuple. And then def size, this is taking a tuple. And obviously we could name these all the same thing, the value going in. It's just for readability's sake. And then tuple size built-in function, and we're just passing in the value. And then we can save this, and we have 3 of our data types handled here. So let's see, the size protocol, I think I read that. We didn't implement the size protocol for lists, as there is no size information pre-computed for lists. And the length of a list has to be computed with length arity 1. All right, so now that the protocol defined and the implementation's in hand, we can start using it. All right, so now we can go back to our terminal. We can recompile. I'm going to clear this so it's at the top, and we can call our size protocol and then our size function. And now we can pass in a string, and we get 3 back. So that is the size of our string. So that's how many, I don't know why I want to say, yeah, bits. That's the size, yeah. And then we can do size.size, and we can pass in a tuple as well. So OK Adam, and then hello. And now when I hit enter, we get 2 because it's a tuple with 2 items inside of it. And then we can do size.size and pass in a map with a key label and then a value, some label. And then we can close off this map, close the function, and we should get 1 back because it is the size of our map has 1 item inside of it. So that's pretty cool. Passing in a data type that doesn't implement the protocol raises an error. Okay, so if we try to pass in a list now, size.size, and we're just going to pass in a list of 1, 2, and 3, we get protocol undefined error. Size is not implemented for type list. All right, So it's possible to implement protocols for all Elixir data types. So you can write protocols for atoms, bit strings, float, function, integer, list, map, PIDs, port, reference, tuple. Protocols and structs. The power of Elixir's extensibility comes when protocols and structs are used together. In the previous chapter, we learned that although structs are maps, they do not share protocol implementations with maps. For example, map sets based on maps, are implemented as structs. Let's try to use the size protocol with a map set. Okay, so now we're going to go back to our IEX shell. And if we create a set variable, and we're going to set that equal to a map set, an empty map set, and then we're going to just say that it equals, and then the value is map set.new. So all we're doing here is making sure that map set.new equals the struct map set, and then we're setting it to the variable, or binding it to the variable set here. Undefined. Man, I am struggling with the camel casing. All right, so now we have our map set new empty list here, set to our variable set, right? And now if we use our size protocol and we pass in set, we get it is undefined for type map set, and then in parentheses a struct. All right, and instead of sharing protocol implementation with maps, structs require their own protocol implementations. Since a map set has its size pre-computed and accessible through mapset.size, we can define a size implementation for it. So we can go ahead and jump back to our code, and we can go ahead and do our def implementation for our size protocol for map set, and then we're going to write a function def, and we need our size, and this is going to take our set variable, or the argument it takes is we're going to call set, and then map set.size will take our set that we pass into it. All right, so let's see. Now, if you desire, you could come up with your own semantics for the size of your struct. Not only that, you could use structs to build more robust data types like queues and implement all relevant protocols such as enumerable and possibly size for this data type. All right, so let's go ahead and just recompile. I'm going to clear this so it's at the top. And now if we go ahead and call our size with our map set, we get 0 back because set was an empty map set. But so now we implemented our protocol for structs and map sets. Whoops. All right, so let's see if you desire. All right, so def module user. All right, so we're going to create a user here. We will go back to our project, our VS Code. All right, we're going to create a new file, and we're going to call this user.ex, and this is going to be a def module user, and then we're just creating a struct here, and this is going to implement, let's see, we're going to have a name and an age. All right, great. And then now we can just do our implementation here. So we have our user, and we want to implement our size protocol, right? And this is going to be for a user struct. All right, and then inside we just have to take care of our size function, and it looks like we don't care about the argument passed in, and we're going to just return the value 2. So we implemented a protocol for our module user, right? And if we pass in our struct user, it's just automatically going to return 2 for us. So this would be our custom implementation of our size protocol. So let's go ahead and recompile this and just test this out. What does this say? The size protocol has already been consolidated. has no effect if you want to implement protocols during tests, blah, blah, blah. Okay, well, let's try it. So now if we say, let's say size.size, and then let's create our user here, and we have a name, Elixir, and what was the other one? Age. It just turned 12, right? All right, so if we do this, we should get 2 back. So we have our custom implementation for our user struct, or I should say our user module, which is pretty cool. All right, back to the docs. So that would be the custom implementation where you can just kind of control what you want spit out, and then implementing any. Manually implementing protocols for all types can quickly become repetitive and tedious. In such cases, Elixir provides 2 options. We can explicitly derive the protocol implementation for our types, or automatically implement the protocol for all types. In both cases, we need to implement the protocol for any. All right, so deriving. Elixir allows us to derive a protocol implementation based on the any implementation. Let's first implement any as follows. All right, so if we go ahead and, oh, sorry guys, my mouse pad moved with my hand. So we're gonna go into our size protocol, and we're gonna just implement our any type. So we're going to say def implement for protocol size, and this is for any. And then we can just do def size function. We don't care about the parameter being passed in, and then we're just going to return 0 here. So this implementation above is arguably not a reasonable one. For example, it makes no sense to say that the size of a PID or an integer is 0. However, should we be fine with the implementation for any, in order to use such implementation, we would need to tell our struct to explicitly derive the size protocol. All right, so save this, and then let's see, derive size. All right, we're going to create a new module here called other user.ex def module other user. And then we're going to say the @derive, and we're going to say it for the protocol size. And then we're creating our def struct here, and this is going to take the same keys as our other user, so name and age. Okay. All right, and then when deriving, let's go back to here. Let's see, when deriving, Elixir will implement the size protocol for other user based on the implementation provided for any. All right, so if we go ahead and let's see, save this, and then let's recompile our project here. If we try this with other user now, we're going to get 0 back. Yeah, okay. So using the attribute derive, we're implementing size, but it's going to fall back to using any. All right, now the fall back to any. Another alternative to derive is to explicitly tell the protocol to fall back to any when an implementation cannot be found. This can be achieved by setting the fall back to any to true in the protocol definition. So in our size protocol, we can go ahead and use our module attribute. So we can say our fallback to any and set this to true. All right. And let's go and continue reading. So we did that. As we said in the previous section, the implementation of size for any is not one that can apply to any data type. That's one of the reasons why fallback to any is an opt-in behavior. For the majority of protocols, raising an error when a protocol is not implemented is the proper behavior. That said, assuming we have implemented any, as in the previous section, so what we're doing here, Now all data types, including structs that have not implemented the size protocol, will be considered to have a size of 0. All right, so if we go ahead and recompile, now if we do this again, we're still going to get 0, right? I'm curious. Let's see, size. Let's just try. We don't have one for list, right? And we got an error before when we tried this. And so now, since we implemented the fallback, we now get a 0. But then we also have it implemented for user, and we get 2. So it's not automatically falling back to any anymore. So that's pretty cool. So which technique is best between deriving and falling back to any depends on the use case. But given Elixir developers prefer explicit over implicit, you may see many libraries pushing towards the derive approach. I think that makes sense, right? But personally, if I was implementing protocols, I would prefer an error instead of handling all types, right? That's just me. All right, so now built-in protocols. So Elixir ships with some built-in protocols. In previous chapters, we have discussed the enum module, which provides many functions that work with any data structure that implements the enumerable protocol. So we have our enum map. I guess we might as well just play with these examples. I'm going to just clear this so we can see. So we have our enum.map, and we can pass in a list here of 1, 2, and 3. And then we can pass it into a function where we're going to just multiply each of these by 2. So we're just doubling the values. All right. And then so when I hit enter, we get 2, 4, and 6 back. And then you'll remember that we also have enum reduce, which usually has an accumulator and will reduce a list or an enumerable, collection, whatever it may be, into one item. So if we reduce, we can do the same thing. We can say, so we can say 1 through 3 here. Our accumulator starts at 0. And then we can pass it into the function. And then so each item, the accumulator will just be, so they're just being added together here. So 1 through 3, so 1 plus 2 is 3, plus 3 is 6. We get 6 back. So another useful example is the string.chars protocol, which specifies how to convert a data structure to its human representation as a string. It's exposed via the toString function. So if we do toString and we pass an atom hello, we get our string back. So toString. My keyboard really wants me to type hell. And we get our string back. And then you can notice that we can also do string interpolation. So we can say age, and then we can do the hashtag, and then inside of curly braces, we can pass a number in, an integer, and we get a string back. And this snippet only works because numbers implement the string.chars protocol. So passing a tuple, for example, will lead to an error. So it works for integer because numbers implement string.chars protocol. But if we try the same thing for a tuple, so we're going to just opening curly brace 1, 2, 3. All right. And then if we try to interpolate our tuple into a string like this, oops, tuple, curly brace, string, we're going to get an error because the protocol string.chars is not implemented. All right. So when you want to print more complex data structures, that's why we always use the inspect, because the inspect protocol is used to transform any data structure into readable textual representation. This is what tools like the IEX use to print results. And then so you'll notice we, like in other examples, and I'm sure in my YouTube videos, if we're doing any logging and we have maps or structs or like anything that obviously doesn't implement the string.chars protocol, we use inspect so we get a readable output from it. All right. Let's see. What is this for? Keep in mind, by convention, whenever the inspected value starts with a hashtag, it is representing a data structure in a non-valid Elixir syntax. This means the inspect protocol is not reversible, as information may be lost along the way. That makes sense. So here we're inspecting a function, right? That is taking the first parameter and adding 2. It would return a function, but it's inside of a string, so we would not be able to use that function. So that makes sense, right, guys? That was a good section. That was pretty good. Protocols, everyone. All right, so that was good. Thursday, I will be planning on doing, what is the next section here? Comprehensions. Okay, so we will go over the comprehensions section in the Elixir Getting Started guide on Thursday, 1:30 p.m. Mountain Standard Time. So that will be good. And thank you guys so much for tuning in, and everyone that has been just active and chatting. I always appreciate it, and helping me when I need help, because, you know, there's nothing better than a little pair programming, especially when I'm live. And Wentz, thank you for subscribing or joining Pro. That's amazing. And if you connect your Discord account to YouTube, it'll automatically add you to a private chat channels on Discord. So, you know, a little elite status for you. So thank you guys. And this was a lot of fun. And I will see you guys on Thursday. Oh, and Friday, we have Sasha Jurish, I think Urish, the author from Elixir in Action, and he does a lot of good stuff. He is my guest, so that will be a lot of fun. So make sure you guys tune in, and I'll see you guys on Thursday. Enjoying the video? Show some love with a like and hit subscribe to stay updated. To support me and keep the content free, click join for memberships or pick up a course at elixirmentor.com and get free access to my private community. Let's jump back in.